In this video, we're going to take a look at the second method for solving complex rationals. In this case, this is the same problem we did in the last video. And this time, we're not going to get a common denominator up here and get one fraction, and then a common denominator down here to get the second fraction. Instead, we're going to look for the common denominator for the entire expression. So notice that we have an x minus 3 here. And then the 4 has a denominator of 1, even though we don't see it. So does the 3. And then this last one here has a denominator of x squared minus 9, which is a bit deceiving because you would think that this denominator here is completely different than that one there. However, when we factor this, we'll find that it's actually somewhat similar. In fact, this denominator is a difference of squares, and it factors into x minus 3 times x plus 3. So for the common denominator for the entire expression, notice that there's an x minus 3 here and here. You only need to count it once because there's only 1 in each of those. However, we also need the x plus 3. So the common denominator for the entire expression is the x minus 3 times the x plus 3. So what we're going to do is we're going to multiply the top of the fraction, which is everything up here, by x minus 3 times x plus 3. We're also going to multiply the entire denominator here by x minus 3 times x plus 3. What you'll find is when we do this method in this manner that the fraction in the top and the fraction in the bottom will go away, and we won't have to flip and multiply like we did in the last one. So let's go ahead and do this. When we multiply this times that, the x minus 3's cancel. And the only thing that we have left is 5 times x plus 3. Because this x minus 3 and this x minus 3, when we multiply that, will cancel. However, when we distribute this times the 4, everything stays. So that gives us 4 times x minus 3 times x plus 3, which, if we were to FOIL that back out, is actually x squared minus 9. It's easier to go ahead and put that in its original form. So this here is the same thing as this down here. Now for the next one, we're going to take this times that, which again is 3 times x squared minus 9. Since nothing canceled, it was best to take this and put it in its original form, since this is the same as that. However, when we multiply this times the second fraction, all of this cancels, and we just have a minus 2, like you see there. So now, let's go ahead and simplify this. We will distribute the 5 here and get a 5x plus 15. And then we will go ahead and distribute this here to get 4x squared minus 36. And then you'll distribute this here to get a 3x squared minus 27. And then you have the minus 2, like you see right there. Now we can go ahead and simplify this a little bit farther by adding our like terms. We have a 4x squared up here, and then plus 5x. And then we also have like terms of a positive 15 and a negative 36. And if you go ahead and add those, you end up with a minus 21. And then in the denominator, we have a 3x squared minus 29. And that's your final answer. However, you might be saying, well, this doesn't look like what we had for our answer in the last video. That's because the top up here is not factored like it was in the last video. You can factor it and leave it factored, or you can leave it in this form right here. If you wanted to factor it, you could, in this one here, nothing is in common, so you'd have to use the AC method to factor that. So let's take this part right here to another page and factor it, and you'll see that it's the same. So that was 4x squared plus 5x minus 21. So if we go back to the other page, you'll see that this is the same thing we're going to factor on the next page. So on this, normally when we factor these, if nothing's in common, you can do guess and check. But if you do the AC method, which is the A times a C, or 4 times negative 21, 4 times negative 21 is negative 84. And then you list the factors of 84 to try to come up with this 5. Because the 5 came from adding 2 like terms in the middle when it was FOILed out. So if we look at the 84 is quite large, but we can list all the factors of it fairly easy. We can do a, and the 5 is positive, so we'd want the larger number to be positive. So 1 times 84, which obviously will not add up to 5. And then 2 goes into 84, so 2 times 42, which does not add up to 5. And then 3 goes can go in that negative 3. 3 goes into the 8 twice, which leaves 2 there, which is 24, so it would be 28. And then obviously we have 4 and 21. And then 5 doesn't go into it, and 6 does not go in, or 6 goes into it. So we have 6 goes into the 8 once, which will leave 2 with a 4, so that'd be 14. And we're getting closer. When we add those, we get a 8. So, but 7 also goes into this. 7 goes into 84. 12 times. And notice if we add 7 and 12, negative 7 and 12, we do get 5. So this is the pair we need. This 5 came from a negative 7x being added to a positive 12x, which we found by listing all the factors of 84 over here. So now we can go ahead and rewrite this as 4 terms. And then once you rewrite it as 4 terms, you want to group them. It's always the first 2 and the last 2. And then we look at what's in common to the first 2 here, and there happens to be an x in common. So we factor that out. When you factor that out, you end up with an x times 4x minus 7. And then if you look at the second 2 over here, they have a 3 in common. And so we're going to factor that out. And when we factor that out, 3 goes into 12x. 4 times, so we get 4x. And 3 goes into 21 7 times. So now notice that there is a 4x minus 7 in common. So we factor that out, and that leaves us with x plus 3. So this here is the factored form of the top of our fraction. So if we go back to the other page, this up here is the same as 4x minus 7 times x plus 3. Now we didn't have to factor that, but I did want to factor it so you could see that this and this were the same, because this is how we left our answer in the last video, and this is totally fine to leave your answer that way in this video. So either way is fine. You can either have factored form or non-factored form. If it's already in factored form, just leave it that way. If it's not in factored form, then it's fine to leave it that way as long as you can't reduce. Now I know that 3x squared minus 29 cannot be factored, so nothing here would reduce, so I could just leave it like that. If it could be factored and you could reduce, you would want to do that. Now, how do you know which method is the best? If we take a look at this, let me get rid of a bunch of this so we can look at the original problem. If you have a problem like the one that we did, where the top and the bottom have similar common denominators. So in particular, for this one, I noticed that this is x minus 3, and I noticed the x squared minus 9 is a difference in squares, which will factor into the x minus 3 times x plus 3. Since this x minus 3 was in both the top and the bottom of this entire expression, so there was something in common with the common denominators up here and down here, I would suggest using the second method. It'll be much easier. However, if you find that there's nothing in common with the common denominators up here and the common denominators down here, then you might want to choose the first method. So if all the denominators up here are completely different than the denominators down here, use the first method. If the denominators up here have something that's also down here, then the second method will be best. So that's how you can choose which one to do. In this case, the second method would have been the best, or the quickest. However, I wanted to show you both so that you could see how to do it. So again, if there's something in common down here, like we had the x minus 3 with up here, then use the second method where you multiply the entire top by the common denominator and the entire bottom. And that denominator this time will have to be of the entire expression. If there's nothing in common down here with what's up here, then make one fraction up here by getting common denominators just up here, and one common denominator down here to make one fraction down here, and then you will flip and multiply them.